Welcome to this web lecture on competing objectives and externalities. In this web lecture, I'm going to use the example of Ilda Supermarkets. And Ilda Supermarkets is in the process of entering the Dutch market and would like to evaluate where to place their stores. In this decision, they consider multiple different aspects or objectives. For example, for each customer, the closest supermarket should not be too far away. Then, of course, since they somehow have to transport the goods from their distribution centers to the actual supermarkets, truck accessibility is an important aspect. And, of course, in the sum over everything, opening supermarkets must not be too expensive. So we're now going to look in the first and the third of these objectives, and we're going to look at how we can handle the trade-off between them. Because, of course, they're in some way conflicting. So we have this example. So here we have 3 candidate locations at costs of 2, 3, and 4. And we have several households around them who all have distances to the individual supermarkets. And the first option that we're having when we're looking at how to handle these competing objectives is we can optimize against one objective and then measure in the other direction. So let's look at that. So if we first optimize for costs, then we obviously open this location because it's the cheapest one. We don't open the other ones, but we have a huge distance for this customer down here. And this is, of course, also not exactly what the supermarket might like. If we now look into the other direction, so if we want to minimize the distance for the customer that is the furthest away, then we obviously open all supermarkets, which gives us the customer optimal solution, which has a lot smaller maximum distance, but a lot higher maximum cost. So we now saw 2 very extremal cases, one with a cost of 2, one with a cost of 9, and also very different distances. So the question is, can we do anything in between? One alternative that we're having is we can check all combinations and analyze the trade-off between them and create the so-called Pareto frontier. So let's look how that looks like. So in a coordinate system, we're plotting the maximum distance between a customer and a supermarket and the cost. And then we just plot in all solutions that we're having. So for example, down here we have the solution where we open all supermarkets, which gives us an extremely high cost, but a relatively small maximum distance. While up here we have the other extreme case that we already looked into. And in between we just have all other combinations. The first thing that we see is that these 2 solutions can never be optimal because they're both clearly worse on both objectives than just opening the 3rd store. And this is what we refer to as a dominated solution because it is definitely not optimal. Now the question is, what happens if we consider the cumulative distance instead of the maximum distance? So right now we're just looking into how far is the furthest away customer away. But we could, of course, also look into the average and just accept that some customers are far away. And that is what I would like you to do. The next option that we're having, if we're having competing objectives, is we can optimize against a weighted sum of both objectives. Now let's look into how this looks like. So for example, if we weigh our objectives 50-50, then the customer who is furthest away is this customer up there because we opened this supermarket down here, which gives us a cost of 4 and a maximum distance of 6. If we use a different weight, a weight of 35 and 65, then we open 2 supermarkets, which gives us a cost of 7 and a maximum distance of 4, which is, of course, better for the customer, but it results in a higher cost. So also here we can generate some trade-off. And what I would like you to remember is that setting these weights is not super easy. Sometimes it makes sense to go for 1-to-1, but one thing that I would like you to remember is sometimes it doesn't. So right now, let's just say we're measuring this in a distance in meters versus a price in 1 million euros, then we're going to get a cost of something between maybe round about 1 million, so round about 1, while our distance in meters is giving us something in the range of 1,000. So if we in this case use 50-50 or even 35-65, then we're going to end up with something that actually only weighs one objective and the other one is barely being considered, which means that coming up with a good weight is very intricate and you really have to look at the absolute magnitude of these numbers. There's many more techniques on handling competing objectives. This entire concept is called multi-objective optimization. And if you're interested in that, there's a lot of very good textbooks out there. Of course, Ilda Supermarket does not only impact itself and its customers, but also affects a lot of its environment. And in economics, we refer to this impact on costs, benefits, etc. of a party who did not choose to incur such a cost or benefit as externality. So an externality is an impact on the third party. And there's many examples in transportation of externalities. One of them is greenhouse gases. So for example, the amount of CO2 equivalent that we're emitting into the air. But this is by far not the only thing that we have to consider or that we can consider. So for example, in addition to greenhouse gases, we also have air pollution, which in cities is often judged even more important than greenhouse gas emissions because it directly affects us who live in this city. Then of course we have noise pollution, we have effects on congestion, we have accidents that occur because there's additional trucks on the road. And oftentimes an accident involving a truck is just a lot more severe than an accident involving two bicyclists. And lastly, we also have land use. So of course, for every airport that we build, for every road that we build, for every rail terminal that we build, that takes away some space. And that is of course also an externality on society in general. What I would like you to take away from this web lecture is first of all, what competing objectives are. Secondly, how we evaluate against other objectives, what the Pareto frontier is, and how we handle weighted objectives. So how we can handle competing objectives. And what I would also like you to remember is what externalities there are and what an externality is. And what I would like you to do is I would like you to look into the cumulative distance. Thank you very much.